something. We don't care what it gets us. It can get next int, and it's going to use the atoy function to pass an integer or something like that. We don't care. But now we say get next char. I'm just going to give you some possibilities here to get your imagination flowing. This is just going to give you the next char. We have now simplified this problem because in this case we also don't have to deal with blocks anymore. Blocks are very awkward to deal with because they might have random sizes and they might not come the way we expect them to be. Chars are pretty deterministic. We can say get next char. It might read a block behind the scenes, we don't care. It might read a block from the disk, it might read a block from somewhere else. Again, this is this abstraction layer, we don't care what the operating system does, but we get the next char. And now let's assume that we have a way to get the next char. Just assume that. Imagine wishful thinking, because why not? We have get next char. We don't care yet how this is implemented. This is the funny part about programming. If we can dream about it, if we can think about it, it suddenly becomes real to us. And if it becomes real to us, we can use it even before we've actually written this function. We can write code that uses this function. If we can think about it, then it exists. We just have to write it before we compile our code, of course. But when we write our code, we can just come up with it. And now things are going to become a bit easier, because instead of breaking a string down, the problem was we read too much. And then we have to store one part and break the other part. For a char, we cannot read too much because the single unit here, the tiniest unit in these, is the char. So we cannot read too much. We can only read to the end of line, and if we have that, we have the line. We cannot overshoot the boundary. And if we have that, well, what can we do? Let's assume we have, again, this magic string. We still need a string to store data, but what we can do now is we can say, well, we have a char C, and then we do C is equal to get next, and this is going to be get next char. Okay? And then we say, okay, just append it to that string. So we say append char to a string. Then we put in this string basically. Again, it's an object. We don't care what we put in there. Could be a number designating some kind of string. As long as we can talk about it, we can put an abstraction barrier in between. We don't have to care what to put in here. And then, what char do we want to add? Well, the C char, okay? And if we do this repetitively, basically forever, what we're going to do now is we're going to add an infinite amount of chars, but character by character. But what do we know about while loops? We can break out of them. What do we do? If the C that we just added
is the next line, just break it or return.
We break the loop. So we first add it because it has to be the last character of our line. And then, if this was the last character, we just break out. And then in the end, we just return whatever string was in here as a char pointer. There we go. Now things are becoming a bit easier, right? We don't have to split. We don't have to allocate and free so much. We don't have to take data and split it and join it and throw things in every direction. We've simplified the problem by just doing what the exercise already did once. To make it easier to read line by line, to make it easier to read a file, we read it line by line. To read it line by line, we have get next line. To make it easier to read a line, see, it just is the same thing. To make it easier to read a line, just imagine this as being the line. We read it character by character. Just like when we read a file line by line, we read just a line character by character. Same principle applies. And we've now inserted another level in between, which again makes it easier to read the next char because it just boils down to the same principle. How this one works exactly, I mean, you still need the buffer, of course, but writing this function is technically easier because you don't have to deal with variable length strings anymore. You can keep just the last buffer size. Like when you always read 42 bytes, you can just store 42 bytes as a global variable or as a static variable somewhere. And then you can just say, well, this was the last character I read. Okay, if I want to read the next character, I go here. So you just need to store this data plus this pointer, which is an integer index, basically. And you can just move to the end. And once I'm here and I want to read the next one, I just read this entire thing again and start from here again. So this is easier than having to like join and split and do the other stuff, because it's less of a burden on your mind when it comes to allocating and freeing stuff. You might, of course, need some time to get into how these buffers work, but you would also have to do that for the copying part when you copy this buffer over into your string that you're then going to split later on. You need the same thing again, so it's the same concept still. Okay, so we've now reduced this problem, and now getting the next line is not too complicated. The only problem is how to represent this one. Apart from that, the code is pretty much fine. Therefore, we're now going to concentrate on this, and then I think we're done for basically today. Yeah. So what, like this is a string that can vary in length because we append a char to the string. Normal strings can't do that. If you want to vary the length of a string, you might have to allocate a new data block, copy everything over, and then add the data. This one, because it's an object again, you can just resize it and it will do whatever you need. Because again, we have an abstraction barrier between these going on. This one, like we have some kind of identifier here, and this one can just be replaced behind the scenes without us knowing. So the reallocation will of course happen, but this side will not notice because this identifier is going to be the same in every case. And therefore this code doesn't need memory management code for allocating, joining, and freeing. And then this one is easier to understand because we just append data to string, and how it does that? Well, look into string.c. If you put it into its own file, then it's easier to break big problems into smaller ones because you can now say, well, the responsibility for having growing and shrinking strings is in string.c. This main algorithm is in getNextLine.c, and now you can split this project literally into smaller projects. Of course, for something as simple as getNextLine, the benefits of this might not be immediately apparent because this is now adding one more function, and I have to write one more function. Why not cram it all into one? But if you have pretty big projects, like really big projects, you might need this. You might even need these strings in two different places. Like you have one part of your code that does some kind of input parsing, another kind of code that does something else. You might want to reuse them, and you can. Just by inputting the header and then using the functions to create and destroy these strings. So how do we build these strings? How do we set them up? Again, for every object, it's the same. Remember the constructor function? We have the open command for file descriptors. We have the makePoint function for making points. So how do we make a string? Wow, right? Awesome. Constructor function is going to return something which is our str. We don't care what it is right now. It could be anything. Now, I'm going to ask you, what functionality would you expect from your strings? Is there anything you wish that your string could do? Like anything that you usually do with strings that really frustrates you to the core, what do you see? We already had resizing them. Something else, maybe. Splitting? Joining? Maybe getting the length, str length. Well, str length is easy, but you have to now check it. Anything else? I think that's basically what you need. So, my personal convention, if I say make string, well, I use string underscore for every function that operates on a string. It's just a naming convention. So every function that operates on a string starts with a string underscore so that I can keep track of what these functions do. Because if I just say append char and you don't know what to append it to, I mean you can append chars to a string, to an array, to a log file, I don't know. So it might be best to call it string append char, log file append char, I don't know, whatever you want. But naming is quite important. Now string append char takes this string again as the first one, and char C, of course. This might be one thing. Another thing might be string append a C string, so a string, a char pointer, basically. Or maybe string append string, like a string that was created by using make string, because they are not the same as char pointers, or might not be. Or let's call this str, and then str. If you call this str1, it looks a lot like string join, which is what I don't mean. String join creates a new string out of two strings. This one will append this one to that, modifying this one. This one will be modified. That's a big difference. Because now this one is going to change its length. In the standard C string join, you cannot do that. You get a new string because it has to be newly allocated. For this you can do that because this abstraction barrier again, or whatever you want to put in here, could be anything, allows you again to swap out this pointer with a reallocated thing. I'm drawing into that, but I think you get the idea, right?
So it's like the same thing, but we don't know that it's happening.
Yes, you don't know what's happening, and you don't have to know as long as it does this. Because this is what you want to do. This is what you care about. Like, you don't want to care about memory allocations. If you write an operating system, you don't want to write memory allocations all over the place. You want to write memory allocations where you need them, but once you have them written once, you don't want to write them again. So the point is, put them into one place, and then don't worry about them. These functions will take care of everything. There's just one little thing. Of course, in the end, we might have to delete the string, because the system will not automatically know when we don't need the string anymore, because C doesn't have garbage collection as it's called. C doesn't automatically clear data, and that's exactly the problem